Okay. Well, welcome back for part two of disclosure within disclosure. So we're going to go ahead and get started. And this is the second part. We're going to go deeper into Spielberg's Disclosure Day movie, and we're going to look at something that I think is deeper. And I think we maybe can have a conversation about this. That's another major theme running beneath disclosure of ETs. So, at least this is my interpretation. This is what I'm seeing here, and love to have more conversations about it. So let's just jump back. Let's just jump back into it. So let me share my screen. And pull up the presentation. I'm going to share it. Okay, there it is. All right, so we're going to get going. Okay, so I've titled it, if you didn't see part one, maybe you should go back and watch part one. But this is disclosure within disclosure. I've noticed with the some of the gematria and some of the numerology, there's some very interesting themes that are popping up. And so I want to explore some of those a little bit deeper here. So let's get into it. So if you're not familiar kind of with my mathematics, I have some other videos on the YouTube site that you can look at. I also have a book that I published a few months ago called the 363 Code, which you could find on Amazon, which will go deeper into aspects of the mathematics. And but everything I'm seeing here in this concept of how nature uses ratios and also proportions in mathematics. And this is the divine signature, and ultimately the proportions will lead to geometric forms, and that geometric form is the divine is language. And these forms will show themselves in nature, and a lot of people are familiar with the Platonic solids named after Plato, and these would include the tetrahedron, for example, octahedron, also icosahedron, dodecahedron, for example. And so these are some of them, and we can go into aspects of those those geometries and look at the number of faces, the number of points or vertexes. And we can also look at angles and things like that. And but right now, I'm just going to just give you an idea that if we're going to understand nature and the divine language, we have to at least engage geometry, not at a high level, not with proofs or anything like that, none of that, but just some basic concepts about geometry. And so also relationships become what's so important when we're comparing something. We can't just be talking about a single number, but it's a relationship between, say, two numbers, right? Would be something like the proportions. And everything in these relationships, we have to keep in mind that we need balance. Everything is about balance, and that is a good relationship. It doesn't matter whether it's in the body, outside the body. That is what's important. So let's jump into this disclosure within disclosure. And as I watched this movie, I just was absorbed, trying to absorb as much as I could, and couldn't really write anything down. But I noticed some things that popped up that really struck me as odd. So one of the scenes is I don't really even think it's a clock, but there is when when Wardex, when they actually capture Daniel, and you see Maggie goes to this military site to go get him, and they're getting ready to inject him with something. I don't know what that is, but at least I think it's three times that Spielberg shows, and this was in red digits, the number 11, 22, and 5. And so when I first saw it, I thought, oh, it's a clock. But no, it goes back there three times and it never changes. So it's the same numbers. And if you multiply those, 11 times 22 times 5, you get this number 1210. If you take 1210 and you do mere subtraction off of it, so I talk about what's called iterated mere subtraction, where you take a number, you take its reflection or its mirror, you subtract it to. And in this case, you get, well, look at this, 1089. And so if you follow my mathematics, 1089 is the first fundamental unit. This is, I identified a series of numbers that on mere subtraction, iterated mere subtraction, they won't collapse into the zero. And so they keep recycling, and they never become perfectly symmetric, and so they don't collapse into the zero. So it's almost like you're seeing this continuous loop. And most numbers do not do this. So I talked about four mere pairs in a 1089 family. And by the way, 33 squared is 1089. And so this number 33, it pops up the crucifixion of Christ. That age was reported as 33, Freemasonry 33. This number is all over, but if you ask people deeply what it means, they don't generally know. And so this 1089 I'm going to refer to as the generator, because it will actually give rise, if you multiply by 2, 3, 4, 5, 6, 7, 8, 9, it will give rise to 1089 multiples. So we're going to tackle this one, and this 11, 22, 5. I see it being maybe more than one meaning, clues actually. And so why did they even pick this number anyway? This 1210 is going to be interesting. And then look at this 1089. Also, then the station in which, so there's a TV network and Maggie works there. And ultimately, disclosure happens across this particular station, KCXE. I'm like thinking, well, what's up with that? So if you break that down, you'll see that this 11, 3, C is 3, X 24, and 5 is E. You run just the multiplication off of that. You get 3960. If you do mere subtraction of that, drop the zero, you get 3267. This is the third shell, or this is what I refer to also as shells, but this is 1089 times 3. So that's kind of interesting when you start looking at things that are popping up in the movie. So there's even more. So I'm going to go into this 1210, and I stumbled across this in my math, and I'm going to show you where this number comes from. It's a very, very interesting number. And this particular number has to do with centers of numbers that are not in base 10, but all bases. And most of our math is done in base 10. And most people just that's all they know. And if you see base 8, you wouldn't even know what to do with the numbers. And that's fine because we're so used to base 10. But the concept I want to make clear is that if we find something, so nature really doesn't know numbers. So a specific number is not to nature as as important as a ratio or a proportion. Because in those, and you have relationships, a number. So when I look at numbers in base 10, I want to make sure that if I go into base 8, base 4, base 12, that I'm looking at my whatever I see in base 10 will extend. It'll be universal because nature's language would be universal. So I will be talking about some other bases, but we're used to counting in tens. But we could count in sevens, 12s, 16s. The numbers would look different, but the structures would not be. All right, so this will become important. So I'm going to show you, and I'm going to be using the 1089 family in base 10, base 10 math, because that's what everybody's used to. And I'm going to use n is equal to 4. I'm going to use 4-digit numbers so that you can look at that. And I'll talk about a center in my 1089 multiples. What is that center? What does it mean? And we'll be looking at that. But I do want to reinforce here that this 1210 minus 121, 121 is another like number that's just on fire. But this will equal what I'm going to refer to as the generator, 1089, because it's going to generate, if you multiply it by whole numbers, a whole family. And the interesting thing is when I talk about these mere pairs that I identified, you find them in all bases in math. So these mirrors are universal. And when you find things that are universal, you have a tendency to like pay very close attention to those. All right, so we'll talk a little bit more about that. Okay, some of the characters. I covered Maggie and Daniel in part one, but I can't leave out Noah. So Noah is played by Colin Firth. And Noah, if you break the gematria down, you see this will add to 38, which is an 11. Or if you compress it down to a single digit, you can add those two to it too. This 11 is what I'm really gonna focus a lot on when we do this, because the number of 11 is huge in the system of mathematics. And I can connect this all the way back to ancient Egypt. So this is going to connect to this lattice, this invisible structure that's between me and you. And this lattice I'm proposing is how the energy is capable of basically meeting certain constraints of this grid and flowing, and through coherency, then you will see physical matter emerge. So that's my working hypothesis, and all the math keeps putting me into this same conclusion. Okay, then there's a scene. I'll describe this scene because this is interesting. This scene in the movie is Maggie and Daniel are being chased by Wardex, and Wardex, one of the members of the team from the DoD, is shooting at them and basically pushes their car into a train, and they have to jump from the train, from the car to the train, and it's moving, and it's a very emotional scene, and a lot of just emotion that's flying there. They manage, Daniel and Maggie, to avoid being, hit by a bullet. They get into the box car. And of course, in this box car, there's nothing else but a broken open box with a piano. Now, if you don't find that odd, uh, and not only that, the box is broken open, and you can see Spielberg shows the keys. It's a Western piano. You can see 7 white keys, 5 black. That's 12. 7, 5. Or you could say it's 35. Okay, just saying. And it even so Maggie's is so she's shaken from being shot at and jumping from car. She almost gets hit by another train going the opposite direction. That she's shaking, and she's shaking inside the boxcar, and she's she's thinking because her father had Parkinson's disease that she's triggered that. But Daniel is like, no, and then he takes her hands, and not that he places them on the keys, but also the piano's broken open, and the strings are exposed, and he places her fingers or digits, get this, digits onto these strings. And I'm looking at this thinking, wow. And then this calms her after, and I'm watching and I'm pretty sure, I know she doesn't put her thumbs on there. I'm pretty sure, because I need to go back and see that she puts 8 fingers, not the thumbs, onto the string. And then it's like she goes into stillness, calmness, like almost like a still point. Okay. That I caught. It's like, wow. The whole thing was unusual to begin with. Some kind of message is in there. So we're gonna explore that. Like what, when she's having these, you know, this fear that's overtaken her, what is going on here? What potentially are they trying to tell us? All right, so before we can do this, it's just kind of just a review in terminology, and I'm showing you here the 4 mirror pairs and then this center here, which itself is like a still point. So 1089, and you see, why do I call them mirror pairs? Pairs 2. And 1089, if you run this, look at it backwards, 9801, 9801. Okay, so 1089 can do some, in mathematics, some very interesting things with this number. I'm not going to go into that right now, but so that's one pair. Our second pair is 2178, 87, 12. You can see, okay, those are mirrors. And by the way, biology uses mirrors. Reflections, mirrors, very, very important in nature. 3267, 76, 23, 43, 56, 65, 34, those are mirrors. So you can see each one of these mirrors. There's 4 mirror pairs, and then we have this center point. The center point right here has no pair, but it's a palindrome. It reads by itself the same sequence. So in base 10 math, you see this. And if you do iterated near subtraction, if you take 1089 minus 9801, ultimately you're going to fall into the small loop that goes from 2178 to 6534. And it just goes back and forth, back and forth. Now, mind you, other numbers don't do this. You keep doing iterated mere subtraction, and they will go to 0. So like these are unusual numbers. And then what does all that mean anyway? All right. So I believe these are also geometric structures as well. So I wanted to just, and you can read this over here. This is basically, K. K is 1 through 9. They show you here if K is 5, then 5 times 1089, you'll get 5445. So it's just a little math, not complicated math, but just a little bit. All right. So let's continue on. Let's continue on. So before we get into it, I want to just go over base 10 math, and I want to compare it to base 8 because I'm going to be saying, oh, I looked at base 8, I looked at base 10, I looked at base 12. A lot of people talk about base 12, and they say, oh, well, they use base 12 because we got 12 everywhere on the planet, and 12 is divisible by 2, 3, 4, 6. And so the Babylonians were using this 60 system, and 12 is a very popular number. So I just want to show you base 10, base 8 as examples. So here, B is for the base 10, and then B minus 1 is 9, and B plus 1 is 11. So you're going to see in my system a 9 and 11, 10's right, in the center, and you have these boundaries. And then I'm just showing you how where 1089 comes from, B minus 1, B plus 1. So this is 10 minus 1, 10 plus 1, 9 times 11 squared, or raised to the second power, I should say, 9 times 121 is 1089. So then if you look at this in base 10, it's 1 times 1,000. Then this is 0 times 100, 8 times 10, and then plus 9. So you see this is going to give you 1,000. This is the 0. This is 80 or 8, and then this is the 9. So effectively, this is what you do when you use base 10. Base 8, a lot of you probably never seen this. Base 8, b is equal to 8. We can run through the same math here. So 567 here. This is in base 10 math. Now, if I want to convert this into the number in base 8, I have to do a couple steps. And so you got to take this 567, and then I have to divide by 8, and the largest number that will go in there is 5. If I do the times table, I can get 512. All right. So you can look at your timetables and go through that. And then 0 times 64, and then 6 times 8, which would be 48 plus 7. So this is where the 1 comes from. This is where the 0 comes from. This, because we're in base 8, the 6 is coming out here, but 512 plus 48 is going to give you 560, and then you have to add the 7. So this is the number here. So if I convert the 567 in ordinary base 10 math to over here to base 8. All right, and that's a little subscript 8 here, just so you see it. Okay, so all I'm doing here is because I'm going to talk about, I wanted to know, do we see mirror pairs in other bases other than base 10? That's what I wanted to know, because if the mirrors are important, they'll show up in mathematics in all bases. Right? Again, everybody works with base 10. And you know what? The mirrors will do. So I'm just showing you here base 4, base 5, 6, 7, 8, 9. Here's our base 10. Okay, so how many did I see? There were 9. I showed you those 9. There are 4 pairs, and then there was the center. All right, but you can see there is the universal concept of the mirror pairs showing up. Now, it is interesting because the odd bases, like base 5, 7, 9, and 11, there's no center. So that's what it means by no. There's no center. There's no like 5, 4, 4, 5. So you have to take the numbers and do an average in order to get that. And I'm referring to that as a C. All right, so let's recap what we're seeing here. The mirror pairs are going to be very important, and they're going to pop up in this movie, concepts of them. And so I wanted to show you this, and I'm basing it and framing it all off of our base 10. But the mirror pairs are in all bases. They're universal. These mirrors are universal. And the even numbers all have centers, okay? And then the odds, we can find seams by, taking the average there of the numbers, the surrounding numbers. Okay, so let's go a little bit further. Now, I'm going to just show you the generator, and I'm going to go to base 10 because I've been talking about 1089, and this is what I believe is a square base pyramid equivalent. And 1089 is here, and here's the center. Okay, so I'm not showing you the other members. I'm just showing you what I call the generator. It's the very fundamental, I'll say frequency. It's the base form. And then you can see some other ones up here. You see some A, B, A, B, C popping up because when you get into bases that are larger than 10, then you have more than because we only have digit wise. If you look at like 1 through 9, we have to then accompany with additional digits. But so it's not really that important. I'm not really going to focus on that. We'll just stay down here where these numbers are. And if you look at here, the first thing that you begin to see is that when you go from base 6 to base 7, this number difference is 11. You see that? 45, 56, this is 11. If you go from the even number bases and you jump, it's 22. So already 11 and 22 are showing up here as important numbers. And then we could also do things with the center as well over here. So if we want to look at the difference between the odd bases from their center 3630 or 840, this is your right here, your 1210, right there. And it holds all the way down, okay, through the bases. So that 1210 minus its mirror is 1089. Also, we could do the subtraction between these two here as well. But right now, I'm just going to look at the odd differences. And then we're going to look at the even differences right here. This number here between these two is 1111. And you do it again, 1111. Again. So keep those numbers in mind, but the 11 and the 22, very, very interesting. So I show you this over here because this is a hieroglyph taken out of the Book of the Dead. This is a hieroglyph associated with a funerary scene. And if you're not familiar with the overall gist of this, in ancient Egypt, when you passed away, you underwent a judgment. And in this instance, you've got 14 judges or initiates that are up here. Hunifer is here, has passed away. Anubis, the god of the underworld, is guiding Uniform, and they're actually going to weigh the heart against a feather, Matt's feather. And the concept is that if you've had an excellent life, then your heart would be lighter than the feather, and then you are granted access into see the Lord of the underworld. Anubis is the guardian. Osiris here is the Lord of the underworld. And then you can pass through the gates. And there are 7 gates. It's interesting, these gates. And if you have the right coherency, then you can pass through the gates and go back home to the Pleroma, center of the galaxy. This is Thoth here, describe recording the event. If you don't pass, then Amit, which is this crocodile hybrid, eats your heart. Or if you can think of these as waves, perhaps, and they're coherent, then you pass through the gates, you're able to pass through the gates. But if you have waves that are incoherent, then they just go back into dissipation, and the energy then is taken back. So as you look through here, this is Horus. Horus is 4 sons here, Isis, Nephthys. So there are 7s here that show up in this register. There's 7 individuals over here. And then if you look through here, the initiates 3, 7, and 11. These are showing up in the same color. So I talked a little bit about this. This is definitely connected to the whole story. And I've talked about this glyph quite a bit, and I keep finding more and more and more as far as the color schemes, the numerology, the encryption, and it's fitting tighter than a drum to my mathematics. So I believe that this is talking about the lattice and energy. All right. So let's talk about Noah here, 38, and that 11. So if you go back, and I'm going to show you this 11 because it turns out to be very important. I've talked a little bit about it before, but when I was developing this lattice structure mathematically, in base 10 math, it was b plus 1 and then raised to the second power. And b being 10, 10 plus 1 raised to the second power is 11 squared, or 11 to the raised to the second power. And then 3 is also a very important number. And you see it shows up if I go back here, 3 and 11 are showing up together. And also 7, we'll talk about that too, but 3 and 11 are showing up here together in that ancient glyph. And you can see that 3 raised to the 0 power is 1. And if you just go across here, you can reconstruct this like this is a particular grid. And you can think of it as area. So if something is coming out of singularity, one of the first things you have to do is form like a 2D to be two-dimensional. And so this grid is kind of giving you the formation of something that would be two-dimensional. But if you look at this, this would be 9 times 121 is 1089. And this would be 9 times 121. So this is, or 27, this is 27 times 121. And you get, so you can start to see that the 1089 multiples are showing up in this particular grid. And 11 is a very important, not 12, 11. Okay. All right, so let's go back here, because going back here, then we see the number 12. And I just said, well, 12 is not very important. 11 is. So what's going on here? I'm going to show you something here, but we have 7 white keys, and I've already described this scene in that boxcar. So I just wanted to put that back up here because I want to show you a little bit more. But as we go through here, the number 7 and the number 5 show up in ancient Egypt. Oh, it shows up. And so this is a picture. This is myself and my partner Daniela, and we are in Luxor in Egypt. We're in Upper Egypt, and Seshat here is right here. Tot was over here, but I'm focusing in on Seshat, and you can see if you look closely above her head is a catch it. It's a 7-pointed crown. 1, 2, 3, 4, 5, 6. With this is like a heptagon. I'll call it a heptagram because it's like a star, but it's got 7 points. And then there's an embedded pentagram, 5-point star. 7, 5, 12, 35. If you look at this, or there are 12 keys here, 7 white, 5 black. All right. That's interesting because sound, harmonics, all right, over here. Okay, then what is this? And the historians have a different story than I have to tell for this. Okay, it's different. So let's push on. Over here is just another image of it. Guess what? If you take the scalar circle at 363 degrees, not 360, you can put a heptagon on the inside of it. Talked about this last in part 1, 7 nodes, okay, and you can form this polygon. This is on the inside. And then you can also, so that's 7.7 nodes, you can put a this is a pentagon. Oh, we got one of those in the United States. This is a pentagon with 5 points. Okay, now you can immediately see the points, other than anchoring here at this 1 point, which is the same. This is why we don't have 12, we have 11. and 12 clothing. But this node is at the same position. And we can run through some math. All right, you're probably saying, well, I don't see a star here. I don't see the two stars. Okay, wait a minute. But we can calculate if we want the degrees for these arcs here between the actual node to node and this arc here, or the heptagon as well as the pentagon. And you can do these over here. And if you take these ratios, you get 1.4. It's one order of magnitude away from 14. 7 and 7 go back to the glyph. This is very interesting as well. Okay, so now we can connect the nodes, go from node to node, and I showed you last time for the heptagon, we can form a heptagram that's a 7 and a 3. So if you look at the more of the aqua, this is showing you there's it's 7-pointed star. And if you start here, you notice you end up over here. And so it's 3 nodes away, 1, 2, 3. And then again, you come over here. So 1, 2, for this is from here. Sorry, 1, 2, should be 3. This connection here, 1, 2, 3. And then, oh yeah, there's one up here. Sorry. 1, 2, and 3. And so you're able to connect and form a 7-pointed star. There is a heptagon on the inside here, right here, and then I showed you another heptagon. There's actually 3 heptagons in there. And then the pink here is the pentagon put on the inside. Okay, and then we could talk about where these two cross. I'm not going to go into this, but is there some rich information in here? If you actually look at the self-crossings of where the pentagram, the lines cross only, heptagram only, and then where the 2 cross, and you add those numbers up, you get 45, which is a 9. Okay, yeah, that came up in 2. Okay, so what have we done here? The 7 and the 5. We put a heptagon on the inside of the scalar circle, 7 points. It's a polygon. We then put a pentagon on the inside of that, 5 points. But we anchored at the top. We anchored at the same point here. Let's go back. Ooh, look at this. Okay, so we don't have 12 points. We have 11. Oh, that number of 11. Where did we see that in math? In the lattice, a very important number, wasn't it? Okay, let's continue on. Vortex. This is the group that is concealing all the information, all the videos, crashes, ET crashes. It's the name of the group. And if you break this into numbers, the letters into numbers, do the gematria, then you'll find this is 7, 5. Interesting, 7 and 5. Yeah, it's 12. Okay. Maybe that's just coincidence. So let's go back here. We got the 7 and 5. Again, showing back up there. Okay. We talked about this earlier, but I'm going to hit it again. It doesn't matter if you are in odd bases, 9, 11, 13, 15, 17, 19. You're always stepping by 22. And these different, if you look at these numbers, the jump is 1, 2, 1, 2. 1, 2, 1, 0. That was the 11 times 22 times 5. Okay. Strange. And back here. So we're back here. All right. Interesting. When we look at this, okay, the rabbit hole goes a little deeper. Let me show you something else. So in my system for those pairs, those 4-meter pairs, when I use 4 digits, you can see where n is 4. This is what we've been looking at, and I've been working out of this here. But you can extend my mathematics to 5-digit numbers. All this is all base 10 to 5-digit numbers 6, 7, 8, and 9. And it's very simple because you just stick a 9 on the inside and you get this is 5 digits. So you see, I just stuck a 9 in there on all of those. You go to 6 digits, you stick in 2 nines. So that 7 digits, 3 nines, 8 digits, 4 nines, and so forth. And you see over here, this one is in red because these numbers are the only numbers. If you divide by 7, you get a whole number. These, you always get decimals. What does that mean? This means 8 digits. Collapse it into still. Now, do you remember how many, I think, did Maggie put onto those strings and then she got calmed? I think it was 8. Somebody can verify that. It's a 3-hour movie and I had to go back and I was just thinking, like, the second hand, I'm thinking there was 8. All right. So let me show you this. Okay. So we were looking at 4 digits and I put the heptagon in here and we traced out this heptagram. It's a 7-3. Okay. And then if you go to 5 digits and you want to trace things out, and I didn't really show you how to trace these out in this video, but other videos I did, then you can see other shapes that pop up. This is the one that completely will collapse. Interesting. Little summary slide here. So if we are looking, if we're looking at the math, it's universal, mere pairs in all bases. Doesn't matter whether they're even or they're odd. The steps from one base to the other is 11. Okay. If you look at the center, okay, between even to even, it's 1, 1, 1, 1. A lot of people say, hey, on the clock, I see 11, 11. It's a spiritual thing. It's like, well, might be some math and spiritual things at the same time. Look at this. And then here's the 12, 10. This is if you look at the seam from instead of even to even, odd to odd. So remember, there's no center point in the bases that are odd, and you get the 12, 10. You subtract these two, you get the number 99. Oh, wow, there's another gem in itself. Okay, let's go a little bit further. Let's take the proportion of those two. 1210 over 1111. It's 110 over 101. Look at that number. 1.089, 1089, 10. Oh, wow. That looks like 1089. What's going on here? Well, it's telling you that 1089 is a pretty important number, and this may not be, if we start looking at these ratios, base specific, meaning it's very important in nature. Okay, it's a lot to chew on, so much more. I- I'm just giving you information to think about it. Clearly, I need to spend more time to extend this because there are points in here that I didn't even talk about some of the stuff on the slides. I apologize. I'm trying to make it shorter as a video. I can go through and make smaller videos on some of this. But this mathematics, I see it in ancient Egypt in these hieroglyphs. And I'm looking at these glyphs and I am just blown away and stunned at what this ancient civilization left us in these glyphs. And you say, well, what is it that they left us? What is it that they left us? They left us the structure and the math for this invisible lattice. This is what I believe. And energy can ride on it. And there are certain structures, constraints that are on this lattice. I'm not sure what the lattice is made of. It doesn't have to be made of anything, as far as like people say, oh no, it's got to be made of something. Well, maybe it has no mass. There are constraints placed on it, energy rides on it, and then through the constraints, then I believe we are seeing some of the physical matter. Now, the ancient Egyptians were doing other things with consciousness and higher levels of communication. This is where I want to go with this. I'm just unraveling this this lattice so that we can understand the math, so that we can then begin to access this lattice, do some amazing things. All right, we gotta go. We'll pick back up. Share this with other individuals and get them to come to the site. We're on this journey together. This math doesn't belong to me; it belongs to all of us. And I just don't think that you're going to read about this in a math book, textbook. It's not out there. And and I've been working on this and aspects of it, and it's amazing. And how they made a picture with all of this in there in ancient Egypt means the consciousness level was super high. And why did they do that anyway? All right, we'll talk more about these things. Got to go.